interacting with crystals suspended in the atmosphere. The ice crystals responsible for halos are typically suspended in cirrus or cirrostratus clouds in the upper troposphere. But in cold weather, they can also float near the ground, in which case they're referred to as diamond dust. The particular shape and orientation of the crystals are responsible for the type of halo observed. Light is reflected and refracted by the ice crystals and may split into colors because of dispersion. The crystals behave like prisms and mirrors, reflecting the light between their faces, sending shafts of light in particular directions. They do often indicate that rain will fall within the next 24 hours, since cirrostratus clouds that cause them can signify an approaching frontal system. While Aristotle had mentioned halos in antiquity, the first European descriptions of complex displays were those of Christoph Schreiner in Rome in 1630. Chinese observers had recorded these for centuries, and the first reference being a section of the Official History of the Qin Dynasty in 637 on the 10 halos, giving technical terms for 26 solar halo phenomena. Their distinctive pouch-like patterns hanging beneath cloud bases often form under cumulonimbus clouds, but can also appear beneath other cloud types, including altostratus and cirrus. Derived from the Latin word memma, meaning udder or breast, these clouds were first described in 1894 by William Clement Ley. According to the WMO International Cloud Atlas, mammatus represents a supplementary cloud feature rather than a specific cloud classification. Typically linked with severe weather systems, mammatus clouds suggest a strong storm presence, particularly one associated with anvil clouds. Pilots are advised to avoid areas with mammatus clouds due to the turbulent conditions they signify. Despite their ominous appearance, mammatus clouds are composed mainly of ice and can stretch across vast distances, remaining visibly unchanged for up to 15 minutes. The formation of these clouds involves complex environmental interactions, especially across sharp gradients of temperature, moisture, and momentum. Several hypotheses attempt to explain their formation, each addressing different aspects of these atmospheric dynamics, and one theory suggests that differential warming rates between the moist air within the cloud and the drier air below lead to an instability and convective overturning, resulting in the cloud's lumpy base. However, this theory faces criticism as some observations of mammatus clouds don't align with the expected patterns of air subsidence that originate when the sun appears to be just above or below a layer of clouds during the twilight period. They're noticeable when the contrast between light and dark is most obvious. They usually appear orange because much of the path through the atmosphere at dawn and dusk passes through up to 40 times as much air as rays from a high sun at noon. Particles in the air scatter short wavelength light, the blue and green, and through Rayleigh scattering much more strongly than longer wavelength yellow and red light. Loosely, the term crepuscular rays is sometimes extended to the general phenomenon of rays of sunlight that appear to converge at a point in the sky, irrespective of time of day. In some cases, sunbeams can extend across the sky and appear to converge at the anti-solar point, the point on the celestial sphere opposite the sun's direction. In this case, they're called anti-solar rays or anti-crepuscular rays during the twilight period. This apparent dual convergence is a perspective effect analogous to the apparent dual convergence of the parallel lines along a straight road or a hallway directed at opposite points to an observer above the ground. Cloud. It's a dense, cumuliform cloud formed by intense heat from fires or volcanic eruptions. This heat drives convection, causing air masses to rise until they reach a point where the atmosphere stabilizes, often in humid conditions. Both natural fires and volcanic activity are known triggers for these clouds, with the presence of a low-level jet stream further enhancing their formation. Characterized by severe turbulence, these clouds can generate strong gusts at the surface, intensifying wildfires or other large blazes. Particularly large fire clouds, especially those stemming from volcanic eruptions, may produce lightning, a phenomenon yet not fully understood but thought to involve a charge separation caused by turbulence and the unique properties of ash particles within the cloud. Additionally, the clouds can contain sub-freezing temperatures, with the formation of ice possibly influencing electrostatic activities. Typically grayish to brown due to the ash and smoke, these clouds can expand significantly as the ash provides more condensation nuclei. In 2017, the World Meteorological Organization, WMO, International Cloud Atlas, officially recognized Flammagonitis as the name for these clouds, which, when producing lightning, are classified as cumulonimbus Flammagonitis, a type of thundercloud. Number 6. A fall streak hole. A fall streak hole, also known as a cloud hole, is a large gap, usually circular or elliptical, that can appear in the cirrocumulus or altocumulus clouds. The holes are caused by supercooled water surrounded by droplets and grow quickly, causing the droplets to evaporate and creating a hole with brush-like streaks of ice crystals below. An early satellite documentation of elongated fall streak holes over the Florida Panhandle that likely were induced by passing aircraft appeared in 1986, although fall streak holes are more routinely seen by higher resolution satellites